time to learn how to integrate.
Oh, hello. I didn't see you there.
Lately I've been thinking about integration. Integration is an important part of calculus. In order to talk about and learn about integrals and integration, we actually need to take a step back and look at derivatives again. Most of you remember that the derivative is actually the slope of a function. You take the derivative if you want to find that function's slope. But what if you wanted to go the other way? Going the other way, meaning taking the slope of a function and making it back into the original function, is called integration. The integral, in essence, is really the opposite of the derivative. So we can look at it like that mathematically, as the integral being the antiderivative. Let's see if we can demonstrate the concept of integration mathematically, starting with the function y equals a times x to the n. Now, the integral of y equals a times x to the n is going to be a times n times x to the n minus 1. Now, we know that the integral of that derivative is going to be our original function, a times x to the n. An integral in integration is the opposite of taking the derivative, which is why the integral is known as the antiderivative, which means if we know the exact process used to take the derivative and reverse it, we'll get the exact process used to take an integral. So let's start, for example, with the function y equals a times x to the n. Now, if we were taking the derivative, we could divide it into two steps. First, we'd multiply the whole function by the exponent, meaning step 1 would give us a times n times x to the n. Step 2 would be to subtract 1 from the exponent, giving us a times n times x to the n minus 1, and that's our derivative. In order to integrate, we just reverse the process we used to take the derivative. That means we'd add 1 to our exponent, and then we divide our entire expression by that exponent. So let's take, for example, that derivative that we just took. Y prime equals a times n times x to the n minus 1. To integrate, we'd add 1 to that exponent, making the function a times n times x to the n, and then divide the whole thing by that exponent, making it just a times x to the n, which was our original function, proving that this method of integration, the antiderivative, will give you your original function from its derivative. Suppose you were given a function with a constant, for example y equals a times x to the n plus 500. Well, if we took the derivative of that, we'd get y prime equals a times n times x to the n minus 1, and we'd lose that 500 because we know that the derivative of any constant is going to equal 0. But that means that any constant we're given will give us the same derivative. If we had y equals a times x to the n plus 500, we'd get y prime equals a times n times x to the n minus 1. And if we were given another function, say y equals a times x to the n plus 7, when we took the derivative of that, we'd also get y prime equals a times n times x to the n minus 1. That means that multiple functions with different constants can have the same derivative. So if we're given the derivative, or we're given an original function, how do we go the other way and how do we integrate, incorporating that constant or loss of constant when taking the derivative? Before we integrate, we're going to need to know the proper setup and notation for taking an integral. Now the first thing we need is our integration sign, which is the S-shaped figure. After that comes our function, and after that comes our variable of integration. Now our variable of integration is just going to be whatever variable you're using in your function. So if you had x, your variable of integration would be dx, and for example, if you used y, your variable of integration would be dy. Say you were given the function y prime equals a times n times x to the n minus 1, which is the derivative of y equals a times x to the n plus c. the proper way to denote the change from that derivative to that function would be y equals, and then an integral sign, y prime of x dx. Y prime being a times n times x to the n minus 1. Now, let's say we were given the function y equals a times x to the n. Knowing the proper notation and the steps to integrate, how do we integrate this function? Well, we start by writing it out. We start with that integral sign, then our function y of x, then our variable of integration dx. So, what are the steps? Well, we have the integral sign, then a times x to the n dx, and we just use the process that was the reverse of that derivative. We add 1 to the exponent, giving us n plus 1, and divide that whole expression by that new exponent, meaning we'll have a over n plus 1 times x to the n plus 1. Now we have to add one more little step, which is add a constant of integration. Now, that's represented by the letter c, and it accounts for all the variables that could be in this expression that would be removed when you took the derivative. So that c is a placeholder for any constant expression, or any constant number. Let's try this now with actual numbers. We'll use the function y equals 2x to the fifth. Now, 2 is our coefficient, x is our variable, and 5 is our exponent, meaning n is going to equal 5. Now, when we set this up, we'll have our integral sign, y of x, which is our function, dx. That means that when we integrate, we're going to have 2, which is our coefficient, over n plus 1 times x to the n plus 1 plus c. Now, if we plug in 5 everywhere we have n, we'll get 2 over 6 times x to the 6th plus c. Simplified, that's 1/3 x to the 6th plus c. We can use this method to find the integral of any polynomial expression. Say we're given the quadratic y equals a times x squared plus b times x plus d. Well, if we were trying to find the integral of this expression, we'd set it up the same way, with the integral sign, then y of x, and dx. And if we were able to plug all of those things in to our original equation, where our steps used to find the antiderivative, the opposite steps of finding the derivative, we'd have a times x to the third over 3 plus b times x squared over 2 plus d times x over 1, and then plus c, our constant of integration. Notice each time we've just added 1 to the exponent and divided that whole expression by that new exponent. Let's take the integral of the expression 2x squared plus 5x plus 1. Now set it up with the proper notation, integral sign of the function dx, and use our process, the opposite of the derivative. Add 1 to the exponent of 2x squared gives you 2 times x to the third, and divide by that exponent, that 3, will give you 2/3 times x to the third. Do the same with that 5x. 5 times x to the 1 will become 5 times x to the 2. Then divide that whole expression by 2 will give you 5/2 times x squared. Now that 1 will become an x. And then, as always, you'll have your constant of integration.
Did I give this look?